Hi everyone, welcome to my AI education my channel here on YouTube. Today we'll go over on an overview what makes platforms like this, such as YouTube, so successful, right? Recommendation systems, and a high-level overview on technology shaping personalization and user experiences. So we're going to explore recommendation systems, highlighting how they shape personalized user experience across various domains, leveraging from advanced technologies, in this case, AI. So without further ado, let's go for the presentation. Going to cover the fundamentals of recommendation systems, um, core approaches to recommendation, technical components and algorithms, challenges and ethical considerations, as well as real-world applications with trends. So first, should be discussed the fundamentals. It's a key part to understand. Major goal recommendation systems is to bring a better user experience, right? We want to help users discover relevant items such as like movies, text to read, products to buy, so on, to create a delightful user experience, right? Recommendation systems are among the most powerful machine learning systems that online retailers, for instance, implement in order to drive incremental revenue, and they're replacements for search engines. I would argue to that not replacements. They're complementary to search engines by reducing the efforts in proactive and surprising users with offers that they never search for. They're relevant for them, right? So they learn how to predict um, their user may like to prospective item or content, how to generate recommendation lists of items, and how to predict click-through rates, abundant features, right? So we have lots of features here. Main benefits are twofold, right? On one hand, largely reduce users' efforts in finding items and content. And on the other hand, I also add business value on the other side of platforms to service providers. That's also an important source of revenue. So some types of recommendations, they are mainly two, right? Explicit and implicit recommendations. Explicit, as the name says, like the user itself, herself or himself, um, input their preferences, right? Such as ratings and feedback, thumbs up, thumbs down, or number of stars, to give feedback to tailor suggestions. Whereas implicit um, recommendations, they analyze past behavior, right? So they are implicit from mainly browsing or purchase history to infer future preferences. Key domains are e-commerce, for sure, right? We all buy items in e-commerce, platforms such as like Amazon, eBay, and so on. They personalize the product suggestions there, enhance shopping experiences, and increase sales. Media streaming, it's redundant to say which ones. Um, Also, social media content, right? Mainly to keep users engaged and connected. And also a good there to be explored and personalized marketing. So marketing campaigns that utilize recommendations really personalize what consumer would be inclined into engagement, either through purchasing an item or watching content or listening to content, um, such as a song or in like a TV show or movie. Core approaches. Here we're going to discuss main technologies behind recommendation systems, including collaborative filtering, content-based, and hybrid models, blending both techniques, right? Um, so collaborative filtering, what we're seeing here is like based on user preference. As the name says, collaborative filtering. We analyze preferences and behaviors of similar users. Here in this case, like if we're anchoring this user, whatever similar user to herself here, like will be helping the algorithm predict what this user will like in the future, what it will give like 5-star rating, right? Or thumbs up, or even purchase an item, right? So we are leveraging from the community here. All this data to predict what our user might like. And they provide personalized recommendations by matching basically user behavior with similar users, right? You find people that look alike you, like in their preferences, to recommend you what they watched and liked, uh, um, to what you might like, they have not watched or purchased in the past. Um, On second one is like content based, right? This is like a typical approach to be used also in post start problems, right? This is like you have a new restaurant that came to town, like a veggie restaurant um, that just came up into a platform, but no one knows about this restaurant, right? So there are several veggie consumers that would definitely like this restaurant, but they will never know if they um, use we will use like collaborative viewing here. So we need to base this on content, right? Our content filtering techniques maybe get like those user preferences on what type of dishes they, what kind of food they like to eat to recommend this veggie restaurant. So we're gonna anchor based on the content, based filtering analysis on the profiles to identify preferences and recommend similar items. That the user has liked in the past by analyzing attributes in user profiles. And the last one will be like a hybrid, right? That blending to a specific degree both approaches. They would embrace both collaborative filtering and content based. Um, Typically, we see improve the recommendation accuracy. Hard to make a strong argument there because user preferences they change a lot, right? There's no golden algorithm that will solve through time like everything. Like recommendation systems, they require a very operational approach and a discipline of testing and learning to keep engagement in the platforms evolving and growing. So, in general, hybrid models they're robust because they embrace uh, both types of algorithms, their strengths and tackling their weaknesses, right? Complementing each other to some extent. Some technical components in a high level. We're not going to get into lots of detail here. We're going to include mainly how data is collected and processed, algorithms powering recommendations, and how the performance is evaluated. On the data collection side, this is key because data is food to AI, and as a RecSys, it's an AI algorithm, right? We need to have high quality data gathering, like collecting accurate, relevant user item um, um, data, right, is essential, right, to effective recommendations. If you throw trash in, it's going to be thrown out trash as well. So that's table stakes. Also, data cleansing, right? Removing errors, inconsistency to enhance the analysis reliability. Also, normalization and transformations are quite common in recommendation systems, right? To prepare for analysis by the algorithms. On the algorithm side, the foundations, for instance, like we're going to touch here mainly on matrix factorization and neural networks. On collaborative filtering, we have also an approach like there is like typical nearest neighbors, right? Once we translate all those preferences into allow me to be a little bit more technical here, to the vector space, right? So we're gonna translate into into numbers basically that the algorithm can read those representations in the data and find similarities. So you're gonna find the nearest neighbors there in the vector space. But to collaborate filtering into some algorithms and nearest neighbors, so if you find like sparse data, especially in explicit inputs, because most users don't rate their items that they purchase or what the content that they watched or listened. So um, we there are some workarounds, right? Here with some more robust algorithms such as matrix vectorization techniques and also neural nets approaches. Here, matrix factorization mainly uncovers hidden patterns by decomposing large data set into latent features for analysis. Um, and neural nets also part of like this NFTs. They can model complex user item interactions, also enabling improved predictions compared to traditional machine learning models. So they can identify more complexity like in the data patterns, and therefore they will do better predictions. Some evaluation metrics. There's no rule of thumb on evaluation metrics here. Here will be like more on the likelihood that that a user would um, like this recommendation that the content will be relevant or the product will be relevant. So we have a typical classification metrics, F1 score, precision recall. But I think most importantly is like user satisfaction, right? Because it captures the overall quality and relevance perception of recommendations. So translating those into specific business outcomes that are translated into technical metrics from the algorithms um, is definitely key here to grow user satisfaction and therefore make this value creation positive cycle successful, right? Um, some challenges and ethical considerations, which is super important here. Addressing data sparsity and scalability, so sparse data limits um, the effectiveness of our recommendation systems by merely sparse data is mainly like most users don't rate, right? So they more on explicit, and but on the other hand, also implicit can be quite noisy, right? The data might carry lots of bias. For instance, like if you watch the movie in Netflix, it doesn't mean that you like it or not, right? And if you don't rate it, it can be lots of it, right? So those are challenges that need to be overcome, right? By those recommendation approaches. Also the need for scalability, right? They require advanced algorithms and infrastructure to maintain the quality, right? Also, latency here is like a super important a metric here on user experience, right? If what you actually have to come up with, like what usually those platforms build, like it's a layered system to tackle their user base, depending on the profiles they find in their user bases. And handling bias, like now in the ethical part, like which is like very important. You have to handle bias and ensure fairness, right? I think here what you need to do is like really fight for freedom. In that sense, doesn't matter if you agree or not with opinions, right? They're shared and the content there as long as it comply with the law, right? So bias in data and algorithms, they cause unfair outcomes, also affects like decision making, right? Strategies have to be employed, right, to detect and mitigate those biases and promote fairness and inclusivity. Also toxic content, right? Those have to be filtered out. Also, user data privacy is a big challenge for recommendation systems. Protect the user data is essential, right? To prevent unauthorized access and misuse there. Um, Also, explainability, right? You need transparent systems, right? What lead people to like an item should be critical, maintaining user trust, right? So, and complying with regulations. Last but not least important, you need to comply and adhere to privacy regulations is crucial. Right? Otherwise, in the long term, you lose credibility. So those are mainly three items here, like three topics here are tied together, right? And some real world applications to finish now, like in trends, right? We have e-commerce, as you guys suspected, probably. E-commerce platforms, they boost sales by suggesting products, and media streaming, right? Mainly what we have, like personalized content and enhance user engagement. Also, social media platforms and personalized marketing, right? We have LinkedIn, we have YouTube. YouTube is more into media, but also like Facebook, Instagram. Right? They in the feeds uh, personalization, the recommendation system they play a key role there and key uh, building block on those platforms engagement. And also target advertising, right? Marketers, they use the recommendation data to deliver target ads and promotions. They are tailored to user preferences, right? Those are also like tied together, right? Social media with marketing there. It's like that's what really makes those companies um, really succeed in monetization, right? Some emerging technologies and trends now, like we have deep learning advances, right? It's a key tech driving innovation in AI recommendation systems. Also, contextual and real-time recommendations. They need to enhance even more user experience by adapting dynamically. This is more an operational challenge. There's, as I said, like there's no golden algorithm that will solve all recommendation problems. You need to really build this like a discipline on keeping that engagement high, right? Explainable AI, right? As transparency, uh, concerns, and demands are increasing, like you need to explain. um, by making all those decisions made by the algorithms understandable to humans, right? So, what are the key features driving someone to like a content or a product, right? And say like features that would feed the algorithm level of importance and be really transparent on this, right? Um, Last but not least, and I think it's a huge area to be explored, is also combine this with agentic AI across domain recommendation systems that would integrate the data from multiple sources and improve accuracy and also user experiences with agentic AI systems that would, yeah, I think increase this engagement more and more as we progress in the field. Yeah, to finish this off and wrap up with this video, thank you for watching, hanging out with me like so far. So we touched on the importance of recommendation systems in this video, also the need of innovation, right, and some ethical practices, right. Ongoing innovation is essential to improve accuracy and user satisfaction with evolving technologies now, like especially in AI, and how we scale this to millions of users. It's a recommendation systems. If you allow me to say, it's like a service to provide to society, right? In the sense of like content creators, also product distributors to really engage with their user bases and their audiences is key here. Like so, um, thank you for watching. That's a wrap, and see you in the next video.